Is La Nina devolving? And there's hurricanes, and maybe a North Pacific storm, too. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 6th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoy the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. If you have a comment or question, write it up down below. We'd be happy to hear from you. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with a $sign on it. With that, I'd like to thank the folks that donated last week. Our regular cast of donators, leading the pack, Coach Nate with a very generous contribution. Thank you, Coach. Evolution Moto, Tim Caston, Our Predicament, always can count on those guys. And then some new contributors, or relatively new contributors, Peter Carpenter, Pierre Morton, and Noam Chonky. Thank you all very much. With that, let's get to work. We'll start off looking at significant wave heights for the entire planet, not just the North Pacific. And we have a relatively active pattern in play. Up in the North Pacific, remnants of a gale that developed here over the northwestern Gulf of Alaska, still producing 18-foot seas aimed to the southeast. Swell is radiating towards Hawaii and the U.S. West Coast. Remnants of a gale that was in the South Pacific, still producing 26 to 27-foot seas aimed north. Swell, as you can see, radiating north towards Hawaii and the U.S. West Coast. Then we go to the Atlantic. Hurricane Kirk pushing north. You can see pretty large seas here, and another system right ahead of that pushing into, we'll call it Europe, with 20-some foot plus seas, and yet another tropical system. This is Leslie down below. So we went from literally nothing going on in the Pacific and Atlantic basin and everything focused on the Indian Ocean and the South Atlantic to now everything is flopped and it's just almost pure madness in the Atlantic, and North Pacific coming on strong as well. And not to be outdone, yeah, South Atlantic, pretty quiet for the moment, but over in the Indian Ocean, there are still 26, 27-foot seas producing swell, pushing off to the north with more behind that. We have an awful lot to cover tonight, so we're going to move pretty fast. But first, we'll start by looking at current conditions in the Pacific Basin, in our home base, the California area, and out towards Hawaii. We're going to start by looking at the Point Sur buoy off of Monterey, California, buoy number 157. We're looking at all the energy that's heading that buoy, and we see all the way up from 33.3 second period, long period energy here, all the way down to 5 second energy, pure wind chop. We see a bit of energy in the 15, 14 second period range. That is southern hemi swell from one of two gales that developed off New Zealand, currently hitting California, and then some wind swell in the mix. Looking at primary swell, 2.9 feet at 9.5 seconds and 315 degrees. That is the just local northwest wind swell, wave heights 2.5 feet, and that's about right. Secondary swell, it says 1.8 at 13.5 seconds, but actually just looking down here, you can see there's clearly 14, 15 second period energy. So I think this is a bit understated. It was surf supposedly in the 2.5 foot range. Then we do the same thing in Southern California, starting with the Point Loma South buoy, number 191 off of San Diego there. Now clearly you can see the southern hemi swell without any interruption from the northwest wind swell, pure swell. I mean, you see energy all about 0.9 of a foot in the 14, 15 second period range. Here we go, 1.7 feet at 14.8 seconds from 207 degrees. That's surf height at 2.5 feet, but actually at top spots, it's a bit bigger than that. And then there is some secondary swell. It says 0.6 feet at 18.6 seconds. But that's really a fragment of this swell here because it is spread over such a broad area. The algorithm here sort of breaks it up almost into two swells, but really it is all part of the same swell. We go over to the south shore of Hawaii. We're going to use the Lanai buoy, buoy number 239. Clearly now there is one swell hitting and fading in California. That is from the first of two gales from under New Zealand. This is the second swell, a much more prolific swell that developed along New Zealand. We'll take a look at all this when we get to the Hindcast models. This is much bigger, as you can see, with just one band, 1.6 feet at 16.7, and an energy spread the whole way from 20 seconds the whole way down into 13 or 14 seconds, something like that. Pure swell, 2.4 feet at 16.4 seconds from 173 degrees. That's 4-foot surf. That is real surf. And then secondary energy, again, that split thing because the swell is spread over such a large area. So we'll just discount that and say 4 feet is what the actual surf is. This swell is pushing to California as well. So keep that in mind. Then we go to the north shore of Oahu, other side of the island, Waimea Bay, buoy number 106. We don't see a whole lot, but we see this little dribble of energy, 0.7 feet at 20 seconds. That is the leading edge of a little bit of north swell coming from up off the, we'll say, under the northwestern Gulf of Alaska. Nothing huge, but primary swell, 0.9 feet at 19.4 seconds. It says 107 degrees, but that's not right. It's more like 340 degrees. And surf from that, 2 feet, nothing huge, but it will be coming up. All right, so here we go on our tour around the planet. We're going to start in the North Pacific. We're going back in time 1 week, Sunday, the 29th of September. A gale developed producing 24, 25-foot seas, aimed off to the east. Sideband swell from this did push into Hawaii. Here we go. On Monday, Tuesday, you see there was 30-some foot. There we go, almost 40-foot seas late Monday night into early Tuesday. Most of that aimed up into Canada, though, not down at Hawaii or the U.S. West Coast. But swell from this system did arrive into California. I think it was on Wednesday. No, it was on Wednesday, but it peaked on Thursday. I mean, there was actually surf in the San Francisco Bay Area, a couple of feet overhead, a longer period, 15-second period, and 6 waves in a set sort of thing. It was a good little test of what hopefully we are in for as we get deeper into the winter months. Another system, now let's go back in time and look at this real quick, because you don't typically see this during a La Nina year, but off Japan there was a tropical system that was on Tuesday, Wednesday of last week. It pushed up into the Bering Sea, went extra tropical, producing 38-foot seas. These are the highest seas over this entire domain, going to 42 feet. And then on Friday, it started seeping south with 28-foot seas, just barely clear of the eastern Aleutians, pushing off that, mainly 23-foot seas sort of thing. And you can see the leading edge of this just barely reaching towards the Hawaiian Islands. That's that little bit of 20-second period energy, and also pushing towards California. But expected surf heights from this are not to be anything too exciting. Then we go down south. Saturday, September 28th, a gale developed south of New Zealand, pushing north with 28-foot seas, and then 26-foot seas on Sunday, and then continuing with about, 20, 22, 24, 25-foot seas, even into Monday before fading. That is the swell that is hitting Hawaii now and bound for the U.S. West Coast. So some energy from there, but not to be the last of the system. Yet another gale pushed under New Zealand on Thursday, the 3rd of October, so just a couple days ago, producing 31-foot seas. I think that was about it. Yeah, 31.9, and very close to the Ross Ice Shelf here. Then starting to lift northeast with 28-foot seas. Now, this was Hawaii's at about 158 west, so there. So when it really started pushing to the northeast, probably east of the Hawaiian swell window, maybe some sideband swell from that, but certainly from when it was down further off the Ross Ice Shelf. And then this system fading as we get into today. Another little pulse. Whoops, let's go back one more. Right there with seas at 27 foot. So California has the current southern hemiswell, a New Zealand swell, and another one behind that. And Hawaii has the current decent size New Zealand swell with yet another southern hemiswell behind that. And we are in October. This is good news. Certainly a massive change of pace from where we were from 2 months, from like July 19th or 20th till almost the end of September, there was almost nothing. I think it was like maybe the last week of September things started waking up. Now there's so much going on, it's hard to track all of it. Continuing on to the North Atlantic, a tropical system. This was a week ago off of Europe, kind of fading, not doing a whole lot. Then Kirk starts winding up here. You can see getting strong, pushing to the northwest, targeting the whole U.S. East Coast. Swell from this system is radiating toward the coast. Not super huge because it's a good distance away, the better part of 1,800 nautical miles from Central Florida. That was as of Friday. And then on seas 244 feet. Let's get into Saturday. You see Kirk starting pushing off to the north. It's mainly this push to the northwest that really does the most for producing swell for the U.S. East Coast. And now tracking off to the north and probably not doing anything relative to the U.S. East Coast. Europe, though, beware. Something from this is coming. And right behind that was Leslie. So let's go talk about Kirk for a second. I got a couple of stats here. As of today, peak wind 75 knots. That's about 86 miles an hour. But it peaked on Thursday p.m. with winds 125 knots. That's 144 miles an hour. So good, reasonable, longer period swells expected into the U.S. West Coast. Now, Leslie, down here, it's already peaked. As of today, winds 80 knots. That's 92 miles an hour. Suspect not a whole lot is going to come from that. And then not to be out of the picture, a Hurricane Milton over here. And we're going to do a deep dive into that in a minute because that really is going to affect Florida considerably. So we're not ignoring it. We're just not going to talk about it right now. Quick review of the South Atlantic for the past week. We'll just roll through this. Yes, one little gale with 30-some foot seas, but falling southeast, not doing a whole lot. Another system behind that, 28-foot seas on Wednesday, the 2nd of October. And then after that, things kind of have gone quiet. And finally, the Indian Ocean. Right now, not a whole lot happening, or this was actually a week ago. Yeah, there was this gale off of South Africa, produced probably some stormy, windy surf for Jeffreys Bay in that area. Another gale developed on Tuesday, Wednesday, right off of Perth in that area, plowing right into the coast there. And then some more systems behind that. Nothing super impressive. Let's see. Oh, and there we are. We're at the current frame. But there is things in the forecast if you believe the models. All right, let's look forward. We're going to focus again on our main forecast area, California, Hawaii, which really focuses on the North Pacific. It is that time of the year. It is the fall. We're starting by looking at Jetstream level winds. These winds up about 30,000 feet. Help support the formation of gales when those gales form. Help direct their track. We're looking for a trough, a dip in the jet to the south, just like we see here. Let's get ourselves oriented. Japan's right under here. Kuril Islands, the Aleutian Islands, Alaska, Canada down into the U.S. and California down here. The jet falling south, that helps create a counterclockwise flow aloft and down at the ocean surface. That is the hallmark of low pressure. Of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface, generate seas. As the seas radiate away from the fetch area, the lesser period elements fade out, exposing pure swell. And of course, swell, when it hits your beach, turns into surf. So we have a trough in the upper atmosphere being fed by 120 knot winds. And that is what is supporting that little swell that is just starting to show on the Hawaii buoy now. That's all good and fine. Notice the trough kind of persists even into Monday and Tuesday. And then winds start building in the jet as we get into Wednesday. Still just digging out a trough, another decent trough on Thursday, October 10th in the Gulf of Alaska, but it is the one behind that. Look at winds building here, theoretically to 200 knots. That's a lot of energy aimed southeast. Now, just barely clear of the eastern Aleutians, but digging out Friday night into Saturday. That is a legitimate looking winter type trough scenario and holding. I mean, so the point of note here is, and we're 174 hours out, all this energy has really been focused on the northwestern Gulf of Alaska. That is pretty typical for early fall season. It's also pretty typical on La Nina years It just smells like a La Nina year, especially given the immense heat in Northern California. To get multiple 100-degree days or 95 plus degrees, on the coast in Northern California when it's 85 degrees or more, that's exceedingly rare, and especially late in the season. But it's happening right now, and another, I think, day of it is forecast with things before things start to mellow out. That smells of a lot of high pressure in the area, and that also smells of La Nina, even though when we get into the hard data, you're going to see there's no clear signs of La Nina, but this is that theme that's been going on. Higher than normal pressure, at least perceived in the Pacific Basin, that has been there for years. We think it's attributable to the PDO and maybe other things. But anyway, we'll get into that more in a bit. Regardless, at the Jetstream level, North Pacific looking better and coming online. Let's go down to the surface. Surface level pressure, surface level winds, the last little bits of the gale that was in the Gulf that's creating the swell that's currently hitting Hawaii, 30-knot northwest winds, sort of getting traction, but really this gale is all but over. And there you go. As we get into Monday, 25-knot winds, and it's pretty much all over. We know there is more coming. Here we go. So first off, a local gale, as we get into Thursday evening, is forecast. Let's go back just a couple of frames here. Starting to develop on Thursday off of Oregon, we'll say. And this is not going to be a huge system, but 35-knot northwest winds off of California. That's interesting. That is certainly a big change. A stronger gale developing in the Bering Sea, again, following that same pattern, just like a machine. Jet ridging in the Northwest Pacific, then falling over the Northeast Pacific, and a tropical system going to the north. Continuing on into Friday, 45-knot northwest winds, the earlier low, starting to get absorbed in this main system. Further on, 45 to 50-knot winds Friday night. The tropical system looking to recurve. As we get into Saturday, 45-knot northwest winds in the Gulf of Alaska, targeting for sure California and Oregon, but also good sideband energy down into Hawaii. And then that starts fading. And look at this, the tropical system starting to fall to the southeast. Maybe going extratropical. It's a week out. Don't know if I believe the models, but at least it's a step in the right direction. And then finally, what we've all been waiting for, significant wave heights for the North Pacific. All right, our current gale fading out with 19-foot seas over a small area. That's probably good for like some 10 or 11-second period, maybe 12-second period residual background swell. That fades out. We're looking for something better. First up, a little gale developing off the Pacific Northwest on Thursday, producing 20-foot seas over a tiny area. That's good for, 12 or 13-second background swell while we wait for the main event starting to set up over the North Dateline region as we get into Friday, the 11th October, with seas building to 31 feet. Let's see if we can get some more. There we go. And 33 feet on Saturday, theoretically. Again, it's like a week out, if not 34 feet. And then fading from there, but over a good size area, you can certainly see swell pushing to all the key targets in our home forecast area. Oops, let's go back. And then the new gale building behind that, getting traction with barely 20-foot seas, and actually theoretically something else off Japan. Looks like an improving pattern if one is to believe the models. Then in the South Pacific, remnants of our gale still producing 27-foot seas aimed north, that is today, but then fading from there. We're going to blast through this real quick because after that, not a whole lot happens theoretically. Again, unless you make that leap of faith. Look at this under Tasmania. On Sunday, I think there's two more frames. There you go. You see 35-foot seas pushing under New Zealand in the California swell window. Again, a bit of a reach, but maybe summer isn't over just yet. Then we go to the North Atlantic. Kirk, still developing below that. Leslie, Kirk is the real issue. I'm going to focus on that because we're looking at Europe. Look at this, solid seas. Whoa, what was that up to there at one point? 50 feet targeting Europe, and then pushing, fading some, but still 42-foot seas, and then almost making a direct hit into Portugal as we get into Wednesday and Thursday. Then we'll just run through this real quick. And after that, what is Milton theoretically moving into the greater Atlantic, but fading from there. And we'll go back here, just do a real quick, here's Milton. We're going to get into the details, but you can see it trying to develop as we get into Monday night, just north of the Yucatan Peninsula, and then making its trek across. Now, this model shows more like north central Florida. Official track has it a little bit further south, and if anything, drifting further south. And you see a good amount of seas developing off of, we'll say, the entire southeast coast as we get later into the week. Definitely producing swell, but for the Gulf Coast, many concerns regarding wind, storm surge, and water. Moving quickly to the South Atlantic, we'll just put this in motion so you can see what's going on. A definitely quieter pattern, though you do see still 40-foot seas, but aimed off to the southeast. Not a whole lot happening there. Let's go to the Indian Ocean. Now, this is where things get interesting again. It's still sort of summer, I guess. The fading, well, our summer, it'd be the southern hemi winter, what's really spring. Anyway, we'll put this in motion. Not a whole lot happening until you get into like late Thursday, early Friday. What is this? 39-foot seas aimed well off to the northeast, going to 41 feet, and then hanging in that area, holding well together the whole way into almost Sunday, the 13th of October, and then fading. So the Indian Ocean is not dead yet. Local wind forecast relative to California and Hawaii. Northwest winds pretty light on the coast, almost dead calm, though 15 knots up at Cape Mendocino. Light trades currently for the Hawaiian Islands. As you get into Monday, this little bit of northwest wind pattern starts building. High pressure trying to ridge into the coast. We'll say 10 to 15 knots. Trades light for the Hawaiian Islands. Get into Tuesday, more of a blowout. Minimal northwest winds, while 15-knot north winds along all of North and Central California. Trades light for the Hawaiian Islands. Wednesday, same sort of deal. Thursday, here comes that low off the coast. That is going to cut into these northwest winds. You can already see them starting to die. Let's see, we can go one more click. Yeah, Thursday night, they start fading from 10 to 15 knots. Trades for the Hawaiian Islands. Friday, south winds for Cape Mendocino. This almost looks like a wintertime scenario. I don't know if that's for real. Notice the broad fetch in the Gulf of Alaska. Trades light for the Hawaiian Islands. Saturday, a light wind regime for California. Light trades for the Hawaiian Islands. Gulf of Alaska waking up for sure. The ocean surface getting roughed up. Light winds again on Sunday for both California and the Hawaiian Islands. Just for fun, precip forecast. California right here, Oregon up here, Washington there. Put this into motion. Now, last week, all our rain and snow was limited to north of the Canadian-U.S. border. But we see with the coming low, assuming it forms, that there's actually supposed to be rain into Oregon and even into Northern California on Saturday, not making it south of the Golden Gate, and very light at that, with no snow forecast for the Sierra. Backpackers forecast for the intersection of the Pacific Crest Trail and Tioga Pass Road at 8,700 feet. This is on Tioga Pass Road going through Yosemite. Temperatures generally 50 degrees, 50 to 55 degrees the whole way through the forecast period, maybe dipping down into the 40 to 45, I'll say 45 degree range in the evenings after about, we'll say somewhere in the middle of next weekend. Notice the freeze level, though. It has been up pretty much above 14,000 feet, steadily falling to 12,500 feet throughout the entire forecast window. That suggests that the change in seasons is definitely coming to the Sierra. Surf spot forecast. We'll start in Northern California, Ocean Beach. Surf height's not really anything to get interested until about Monday. 4-foot surf. This is coming from the northwest. This is the beginning parts of the swell coming from the Gulf of Alaska, holding in the 4-foot range, fading some, and then theoretically up into the 8-foot range as we get into next Sunday. Swell sizes, 3 feet at 13 seconds from about 305 degrees, something like that. Then fading out, and then building 7 feet at 12 seconds. That is the local swell from the gale, theoretically off of California. We'll see how all that plays out, but definitely an increase in surf forecast. And there's southern hemi swell in underneath that. We're going to look at that by going down to San Diego. First small southern hemi swell, not big, 2 feet theoretically, something like that, but building as we get midweek as the second New Zealand swell arrives with surf heights 2.5 feet, but it wouldn't be surprising, shoulder high sort of surf, then fading, then theoretically coming up after that. Swell sizes, well, here's our current swell, 1.2, 1.3 feet at 12 to 13 seconds. Next swell pulls in at about 1.8 feet at 15 seconds sort of thing, fading, and then some bigger, more local swell after that. South shore of Oahu, surf size is 4 feet from the current, the second New Zealand swell, pushing to potentially 4.5 feet as we get into Monday. Then you just see the steady downward trend from there. A little bit of background swell from the next gale that tracked across the just north of the Ross Ice Shelf. Swell heights, 3.3 feet at 14 seconds sort of thing as we get into Monday, and holding in the 3-foot range as period drops out underneath that. And then a little bit more, that's more like just wind swell. The next Ross Ice Shelf swell hasn't hit, so I misstated that earlier. North shore of Oahu, surf height 6 feet theoretically on Monday as that next Gulf of Alaska swell hits, then slowly trickling down from there. Surf swell size is 4.5, 4.7 feet at 13 to 14 seconds early, then fading down there, but continuing. Just holding the whole way through the work week, and then that's about it. Latest update from the National Hurricane Center regarding Hurricane Milton. Currently a small but building system in I'll call it the western Gulf of Mexico. Forecast tracking just north of the Yucatan Peninsula here, and then bound in somewhere into central Florida and pushing out off the coast after that. These are the probability for wind speeds, tropical storm force winds, to say the least, probably a bit more. Let's go dig into some of the details here. Earliest arrival of tropical storm force winds into Florida, Tuesday 8 p.m. By Wednesday 8 a.m. over on the Florida East Coast, and then out beyond there into Thursday 8 p.m. in Bermuda. Here is the current spaghetti plot of all possible tracks from many different models for Hurricane Milton. Again, do not use this map to make decisions, seek official info. Tropical Tidbits does a great job of presenting this data, all the latest, updated all the time. But you see the general track somewhere in between, we'll say south of Tampa up into north of Tampa, and then pushing out from there. The track would not be so troubling if the forecast wind speeds were not so high, but here is the model intensity guidance from a whole bunch of different models, though the Consensus National Hurricane Center, their latest forecast, this is as of Sunday afternoon, now puts winds that was only 115 knots, now up to 125 knots. That's 144 miles per hour. That's a Cat 4 hurricane coming in somewhere in the Tampa-ish region. Certainly that bears a lot of attention and a lot of concern. Everyone that lives in that area should be following, dial into your local news, dial into the National Hurricane Center, start watching all the forecast models and try to get a better sense of where this is going. On this presentation here, we're just giving you a general alert. It's coming your way, though I'm sure you know that already by now. But anyway, you can see the range from different models goes all the way from a Cat 5 to a Cat 1 hurricane, but the main cluster in the Cat 4 category as of right now. Again, still a couple of days out. A lot can change, but there's a lot of very warm water and has been for a year and a half now in the Gulf of Mexico. Perfect boiling pot for hurricane development. And here is the actual positions and wind speeds, but right there, 48 hours out, 125 knots. That's 144 miles an hour. And that's right off of the Tampa, generally off the Tampa Bay-ish region. With that in mind, we go back to our local surf forecast, the graphs. We're looking at Sarasota, Florida, surf heights of 19.3 feet. This is on Wednesday at about 2 p.m. in the afternoon. Wind speeds in excess for sure of 49 miles per hour, but that gives you just a general sense of what's going on. Swell heights for pure swell, the most conservative estimate, 14.4 feet at 13.5 seconds, and probably a bit over that, all depending on the track of Milton. Cocoa Beach, Florida, on the east coast, the other side of the coast away from Tampa. So surf heights, it says 8 feet at, that's probably not Val. That's probably a bit on the high side as we get into Monday. Northwest wind swell pushing in, things fading out after that. But then as Milton pushes across the state and starts moving into open waters off the Florida coast, surf heights theoretically building to 12 feet on, that'd be Friday, then fading from there. Pure swell, 9 feet at 12 to 13 seconds. In fact, let's go look real quick. Here's Florida here, Milton off here. This is Kirk off here. We're just going to watch Milton as it evolves Sunday into Monday. Not a huge storm, into Tuesday, and then building while pushing northeast. Now, this track is a little bit more to the north, and you see it pushing in somewhere north of Tampa Bay, and then pushing out off the coast. But then there's this evolving fetch of north winds at 50 knots as we get into Thursday. Now, that's probably shadowed in the Cocoa Beach area, but Daytona, New Smyrna Beach, that area, that's a good amount of fetch raking right down the coast. And then as we get into Friday, the fetch, the center of the gale pulls off the coast, northeast winds aimed directly at the coast. Certainly good for surf production, but a lot of northeast winds and a bit of chop. Take what you can get. Milton finally fading out sometime late Saturday, early Sunday, well east of the Bahamas, and a lighter wind regime sets up. Cape Hatteras Lighthouse also getting, well, first northeast swell from local fetch off the coast, theoretically 8 feet as we get into Monday, falling from there. And for the most part, Milton and its fetch is really going to be aimed from South Carolina southward, though there still is sideband swell in the 3 to 4 foot range forecast as it fades off the coast. And then finally, Portugal, the coast, the Atlantic side there, from the, as Kirk or the extratropical remnants of Kirk push right into the coast, surf heights theoretically 38 feet. This would be on Wednesday, late afternoon. Swell heights 21 feet at 16 to 17 seconds. Now, surfable, probably not, at least not on the initial impact, because winds are supposed to be onshore at 25 knots. Maybe there's a window for some fading swell, though, after that, or some protected place not exposed to west winds on the initial push of the swell. Let's go take a look long-term at the two major oscillations that affect weather and the potential for surf. The MJO, the Madden-Julian Oscillation, and El Nino, Southern Oscillation, NCAl. We'll start with the MJO, the Madden-Julian Oscillation. As most of you know, there are two phases, the active phase and the inactive phase. They rotate around the planet from west to east on the equator. The active phase on one side of the planet, inactive phase on the other. The active phase is our friend. It is like a low-pressure system. It takes warm, moist air at the ocean's surface, lifted aloft. That, in turn, gets sucked into the jet stream, energizing the jet stream, making a stronger jet, therefore making greater potential to dig out troughs and support storm development. We're looking for signs of the active phase of the MJO. The inactive phase is like a high-pressure system. It shuts the chimney off, and the jet stream gets weaker as a result of it. Wherever the active phase is, and remember, it rotates west to east around the planet. When the active phase moves over your ocean, that is good for producing storms, like winter storms well north and south of the equator, but also for generating tropical systems right on the equator. Right, so we're looking for signs of the active phase of the MJO. We're going to look at wind speeds. This is data from and we're just talking about the Pacific at the moment. We're looking at wind speeds from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here. This is the West Pacific here. Those buoys also have wind sensors on them, and you can't see a whole lot, but you get the sense, just looking at the arrows, whatever ones there are. Winds are pretty strong out of the East and the East Pacific, pretty strong trades, that is, over the Central Pacific, and still pretty strong over the West Pacific. Smells like the inactive phase, the MJO. But it's not the wind speeds. The actual wind speed is the anomalies, the difference from normal for this time of year. And in the East Pacific, yeah, it's pretty normal. You just see these little tiny east arrows. They're just basically nominal. Over the Central Pacific, a little bit stronger trades out of the east, and a little bit stronger over the Kelvin wave generation area, the West Pacific, suggestive of not the inactive phase, so probably, or not the active phase, but probably the inactive phase. Let's go look at the forecast for the next 2 weeks. Here we are, 850 millibar zonal wind anomalies. All this tells you is the wind stronger out of the east or stronger out of the west. The yellows are westerly anomalies. That would be the active phase of the MJO. And you see sort of this line going. This is the whole planet on one chart, but the far West Pacific starts about 125 east, so right about there. The and then Ecuador is like at 80 west, so over here. But the main part of the ocean where the MJO does its thing in the Pacific is the West Pacific. Kelvin wave generation from 125 east to about 170 west, somewhere right there. So you see there was like an active phase, westerly anomalies that traversed the planet back in September to early October. But you notice this persistent easterly wind anomaly pattern, and it's strongest like right now. Here's the beginning of the forecast, filling most of the Pacific Ocean. Certainly looks like the inactive phase of the MJO, and that's supposed to go on. This is only 2 weeks. It goes to about October 18th. Now notice a bit of westerly anomalies forecast creeping into the far West Pacific, and you just get the whole sense of the general thing moving from west to east. Maybe the inactive phase of the MJO will be moving out of the area at that point in time. Now, case in point, inactive phase does not mean there is not going to be surf or storms. It just means the likelihood for storm development is something less. Also note, westerly anomalies are over the Atlantic. No big surprise that the tropical machine is firing up. It has a favorable upper and lower level environment courtesy of the active phase of the MJO. So, not surprised to see and what was the statistic I saw? 3 hurricanes in the Atlantic, all simultaneous in the early October time frame. Never happened before. It's happening now. Looking further out, outgoing long wave radiation forecast, OLR. The blue is just areas more favorable for cloud development. Why would that be? Well, if you have the active phase of the MJO, it's lifting warm, moist air aloft. That warm, moist air eventually condenses into clouds, and it would be more cloudy than normal, than the average. So these are anomalies, differences from normal. Right now, and here's South America, Central America, Australia, New Zealand, the equator right there, date line right there. The area we're interested in, the West Equatorial Pacific, dead neutral theoretically right now from a cloud cover perspective. But per the statistic model, a weak active pattern perhaps showing up 10 days from now to 15 days out. The dynamic model suggests a little bit stronger active period starting about 2 weeks from now. So this smells like the inactive phase holding over the Pacific probably for almost the next 2 weeks, which is exactly what that other model we just looked at showed. Let's go dig into the details real quick. Phase diagrams for the same 2 models. The statistic model, dynamic model here. The MJO moves from west to east, from the Indian Ocean over the maritime continent to the West Pacific, to the East Pacific, under the United States, across over Africa, back to the Indian Ocean. The heavy dot is where the active phase is. So, whoops, right there. There it is. So it's in the Indian Ocean right now, forecast to move to the East Maritime Continent 2 weeks from now, per the statistic model, and very weak. The dynamic model suggests it moving to the same location, maybe a hair bit stronger. And one other little thing, you can do this right here. And these are longer range models. Let's see if we can shrink that down. And we're going to go, there's a bunch of models here. You saw the link of where it is on the page. But we're going to the longer range models here. This is the extended model. This goes out a month. Active phase in the West Pacific. Another version of that in the West Pacific. Canadian model. Oh, that doesn't go out. Let's see. And here's the bond, the Australian model. It has it actually pushing through the West Pacific at moderate strength, like the 22nd, 23rd of October. And then another version of it, basically the same thing, not quite as strong. Net result, this all sort of smells like the active phase is coming, but it's going to be about another 2 weeks. The focus will remain on the Atlantic until then. Now, the upper level model, this goes out 40 days. Areas favorable for precipitation. The greens would be the active phase, but this is up at the Jetstream level. Down at the surface, it's like a week to a week and a half behind. This already shows active phase trying to build into the West Pacific and strongest from the 10th of October into about the 20th of October, but add about another 10 days on that to get a better sense of what's going on. So later October into early November, and then the inactive phase forecast after that. You see the active phase, some of it is in the Atlantic, some of it's over Africa into the Indian Ocean. But this suggests maybe less support for hurricane development in the Atlantic a couple days out, maybe a week from now. And then the CFS out model, this goes out 3 months, so we'll just get right down to it. All right, this is, again, the blues are easterly anomalies, the yellows and oranges, westerly anomalies. This is past performance down here. You see there was an active phase that crossed the Pacific. Oh, and this is the date line here. The far west Pacific starts at 125 east, so right there. And the Kelvin wave generation area ends at about 170 west. So the area we're interested in is from about here to here, the whole way up this chart. Blues, easterly anomalies. One can assume the active phase of the MJO, but after that, here come westerly anomalies. And look at after that. Whatever easterly anomalies are forecast, they're east of the date line and even weaker after that. So now this gets into the title of the video, is La Nina devolving? We're going to look at some data, but this is the first little hint that whatever La Nina we're in, it isn't particularly strong and is not forecast to be particularly strong starting about 2 weeks from now. Let's overlay the MJO just for laughs. There we go. Dotted contour is the inactive phase of the MJO. It's supposed to be clear of the Kelvin wave generation area by about October 25th, while the active phase starts building in the west on about the 17th of October and holding the whole way through till about mid-November. After that, the MJO, very weak, and westerly anomalies, which fill almost all the Kelvin wave generation area in late October, start taking over and fill a larger portion of the Pacific beyond, the exact opposite of what you would expect if we're in a La Nina pattern. Let's overlay the low-pass filter. All right, this is a high-pressure, low-pressure bias. This is key. The black solid contour is your El Nino indicator, but when it's over where this is, like the Indian Ocean, that is clearly a sign of La Nina. And the dotted contour, which is high pressure, is, if this was La Nina, the high pressure signal should be much stronger. In fact, it hadn't even been present since the beginning of August, and it's only going to show up about a week and a half from now. But then only one contour and very weak and not having a particular influence, we don't think. That said, the general pattern, at least at this point in time in the Pacific, smells of high pressure, and the general pattern in the Indian Ocean smells of low pressure, just with the way the storm pattern is. Not to say there aren't exceptions, but if this is La Nina, it appears to be pretty weak, and we're going to look at some more data that will challenge that assumption or support that assumption even more. We're going to start with subsurface water temperature analysis in the Pacific. West Pacific here, East Pacific here. This is data from the TAO buoy array. These are the anchor lines on the buoys. You can see there's a big old chunk here of missing data. We're hoping that is out in the process of being fixed now. Anyway, we're looking at the distribution of warm water. The 30-degree isotherm It was at 175 east last week. It's retrograded a little bit. 29-degree isotherm holding steady at about 175, 176, something like that, west. 28-degree isotherm unchanged. 24-degree isotherm, if anything, is built a little bit in the east. But it's not actual water temperatures that matter. It's the difference from normal for this time of year. This just shows, yeah, weak warming in the west, supposedly some weak warming in the east, but again, a big old dead block right there. But notice nothing particularly cold at depth. And though there's a lot of missing data here, and this is suspect, there's another chart that really bears the picture out a little bit more. So here's that same chart, but it not only uses the buoys, but also uses satellite data to presume where warmer and colder than normal water is in the Pacific. And this is really interesting because the whole West Pacific, you see, dominated by warmer water to about 170 west. But there's also like this blocking pattern suggested here. The typical flow of water is always from west to east across the Pacific, be it a warm Kelvin wave or a cold Kelvin wave. If the channel is blocked, it's really hard to get water to migrate one way or the other. And it always starts developing over in this region, not east of the date line. There is a good patch of cold water here with 1, 2, 3, 4, 5, 6. What's that? 1, 2, 3, 4, 5, like 5 degrees Celsius below normal. But also notice warm temperatures here. And if the flow is cut off once this erupts to the surface, there is no more fuel for La Nina. That is interesting. Let's go look at the satellite data. This image shows you the height of the ocean surface. Let's get ourselves oriented. Chile, Peru, Ecuador, Central America. This is the equator here, dateline here, New Guinea's over here, Australia here. It's just the area 5 degrees north and south of the equator that we're interested in, here to here. And what this is a satellite beams radar down at the Earth. You can tell how high the surface of the ocean is based on how quickly the return bounces back to the satellite. Now, the key here is you strip out the waves, the wind waves, the tides, and what's left, you get sort of the average sphere of the ocean surface. Is it higher or lower than normal? If it's lower than the normal, that suggests cold water is at depth. Cold water, of course, contracts. When it does that, the surface water above it will create a depression. Warm water at depth expands. It displaces the water above it up. So you see warmer than normal anomalies here north of New Guinea. There's your date line, your equator. And you have minus 15 centimeters here off of, well, that's the Galapagos in Ecuador here. But the point being, this area of minus 10 centimeter anomalies was a lot bigger last week, the week before that, and the week before that. The 15 centimeter anomalies, I think they were down at minus 20 even last week or the week before that. So this gives you the sense that this pool here is getting less dense and not as broad as it was. Let's keep digging. Upper ocean heat anomalies. This is the West Pacific here. This is the East Pacific here. This is time going back a year. You see the last remnants of our El Nino, the last Kelvin wave, warm water Kelvin wave traversing the Pacific, driven by the active phase, west anomalies from the active phase to the MJO. Here back in November and December of last year. Then here was our first cool Kelvin wave. And notice where it originated from. Cool water off of in the far West Pacific. We had a little warm spurt, another, number 2, number 3, a warm spurt, number 3, 4, and number 5. But currently, notice the building area of warm water. Now, not super warm, and I'm not saying El Nino or anything like that, but you see, and this last cold water Kelvin wave is already fading. It's still traversing the Pacific, but it just doesn't feel like there's a lot of support here in the West Pacific to create another one. Just maybe. Then we go to sea surface temperature, not subsurface, but on the surface now. Now, clearly we have a La Nina signal here. Here's South America, North America, Australia, New Guinea, the equator right here, the date line right there. Here is our La Nina cool pool. It's not even connected to this sort of standard cool pool that sets up off of Peru and Chile. And there's not really a strong mirror image of it over here in the Atlantic either. This looks like La Nina, but at best it's a Madoki La Nina. I mean, about this time of the year, if La Nina was really going to get a grip, if anything, it would be building. You'd see a building area of blue waters along here. At some point, I need to go find a good La Nina and give you the contrast here. But you get the sense that it's here, but it isn't doing a whole lot. And this is the trend for the past 7 days. You see the blues are cooling waters, so there's a mixture of cooling waters and warming waters in small pockets. Nothing really particularly standing out and screaming major La Nina development. Here's the forecast sea surface temperature anomaly trend in the Nino 1.2 area. This is right on the equator there by Ecuador. Temperatures have been sort of pinging around -1 to half a degree. We had a little bit of a downward spurt here in late September, but now we're rebounding to -1.011 degrees, so 1 degree. Now, this is not the official El Nino monitoring region. This is the Nino 3.4 region, the area on the equator south of California out to about the date line. Temperatures today, we'll do it this way, 858 thousandths of a degree below normal. So to be clear, to be La Nina, you have to be below a half a degree, and weak La Nina is half a degree to 1 degree. Moderate La Nina, 1 degree to 1.5 degrees. You see where we are. We're at, 3/4 of a degree, a bit over 3/4 of a degree, and you have to be at that range for like 5 consecutive months, and we're only 1, 2, 3, 4, maybe 5 weeks, 1 month into that trend. So again, once you have cold water on the equator, then it takes 3 months after that for the atmosphere to really respond. So let's keep digging, but all this smells like not much of a La Nina, if anything. So what does the atmosphere think is going on? All right, so we look at the difference in pressure between Darwin, Australia, and Tahiti, okay? If pressure is lower in Tahiti, this index, this combination of the two, goes negative. Well, it's 10.31 degrees, or a value of 10.31 today. But yesterday it was 2. The day before that it was -10. So it's just toggling around neutral. If we go look over the past month, it's been neither, more negative earlier in the month, but really it's not going anywhere. The 30-day average, well, this is the 30-day. This gives us a sort of a look back 30 days, -1.37. That's pretty much dead neutral. And where has this been the past month? Well, if anything, it was more indicative of La Nina back 30 days ago than it is today. But this is heavily influenced, again, by the MJO. It runs about, 4 to 5 weeks active, then 4 to 5 weeks inactive. This influences that. So then you do a 90-day average. Okay, and just look at this. -0.59. That's pretty much dead neutral. And where have we been? Hovering right at neutral for the past month. Let's go look at this data graphed out. Here's a 30-day SOI graphed out. You can see the swings in the MJO. Upward pushes are the inactive phase. Downward pushes are the active phase. Here was our El Nino. Now, Australia Bomb says that you have to be below 7 to be in El Nino category. So here was our El Nino in 2023. And then we get into 2024. And it pretty much just has been hovering at dead neutral today, if anything, falling. Still, about as neutral as you can get. And then last week, we got into a bit of a discussion, or it might have even been the week before that, about the PDO, the Pacific Decadal Oscillation. It's this long-running 25-year plus oscillation that varies between high pressure in the Atlantic and in the Pacific and low pressure in the Pacific. We have been in a cold phase, the high pressure version of the PDO since 1998, right? And, it seems like we're getting some sense that there's been more high pressure than even the PDO might expect, or that you might expect to see from the PDO. So I go, well, let me go dig in and just see Let's see if I can get data, because we have this Southern Oscillation Index data. It's literally a daily record of the surface pressure, same time of the day, measured in Tahiti, and it goes back like 100 years. Well, I couldn't get that data, but I could get the actual daily readings from 1991 to 2024. Here they are in this kind of grayish color, and it's kind of moving in and off the chart. And the question was, is there a tendency for pressure to be building over the Pacific? And there is some discussion that in a warming planet scenario, you'd actually have you'd have more high pressure, more inactive phases of the MJO, punctuated by stronger, more intense active phases of the MJO, or periods of storm development. So I just go, well, if all that is true, theoretically, then pressure should be rising over the Pacific, just in general. So I got all the data, I mapped it out. You see it's wildly all over the place. The average is this blue line right here, which is centered at, I can get the average value off here. Let's see if I can drag that into the chart. 10.74 millibars. But then I could also put a trend line on that. Let's see if we can get all that to fit in. That's the red line. And it starts here at 1,012 we'll say roughly 3 millibars. And over the period, the roughly 30-year period, it went up to 1,013.3. So almost a 1 millibar change over 30 years. I go, well, is that statistically significant? I don't know. I honestly don't know. I'd love to get the data. This data goes back to 1890, I think, or 1880. I'd love to be able to get all the data and then map that out and see if this trend still holds. But I mean, just even eyeballing this, you can kind of get the sense that maybe the pressure is rising some. I don't think it's a lot, and I don't know that it really pertains a lot to the conversation we're having right now. But if you sense that the weather patterns have changed for people that have been around, 60 years and that have been in the ocean for 50 plus years, there is sort of a sense that maybe the Pacific isn't as productive, at least as what it was prior to 97. But I don't know. It's hard to sort out perception from reality. But here is just a little piece of data for your consideration. Here is the sea surface temperature forecast for the Nino 3.4 region, PDF corrected. So this is probably a closer approximation to reality. We are approaching mid-October. Temperature is supposed to be falling to about 0.85 of a degree. Now, this is actually an upgrade from last week. Temperatures barely making it to 1 degree below normal. So clearly in the weak La Nina status, and then quickly rebounding from there. That's in December. So a short and very shallow La Nina forecast. Let's go look at some other data. This is the subsurface temperature profile forecast. Sort of what we were looking at in the other charts. Here's past data. So this is the far west Pacific here. This is the whole planet. So that's the Indian Ocean. The Atlantic's over here. But the Pacific is right here. Date line's right down the middle. Cold water in July, August, September working its way to the surface. I think we looked at this before. October, a cool pool. Here's that blocking warm water. And really, no more forecasts as we get into November. It sort of builds up here in December. But notice, this is the more important thing. The warm water currently in the West Pacific starting to push east, starting to undercut, and if anything, build up that blocking wall in the West Pacific, getting even stronger. Looks like a full-on Kelvin wave as we get into January, February, and March. By March, no cold water left at the surface, warm water subsurface, and that builds as we get into the spring and the early part of summer of next year. This is most interesting indeed. So zooming back up out of the trees, out of the forest, out of the dirt, the overview. Hey, there's a gale forecast in the North Pacific. That looks good. And there looks like there's more behind it. And there's one southern hemiswell on the way for California and another one behind that. and you go to the Atlantic, there's hurricanes. Now that's not good, but it clearly signals the blockade, whatever dam was gumming up the works back the previous 2 months in July and August. That's all but gone. We are fully in the swing now. The doldrums of summer are over, and I think the odds, looking longer term, whatever this La Nina is doing, it doesn't look like it's super impressive at all. In fact, it's about as weak as it could possibly be, probably mirroring what we thought was going to be a super El Nino last winter, which turned out to be pretty much of just a weak El Nino. That means the pendulum didn't swing too far to the left, and it probably is not going to swing too far to the right either. And maybe we're going to end up in some ENSO neutral thing beyond this winter. But right now, things are not looking nearly as bad as they looked months ago. So, doing okay. In the meantime, though, precip forecast, we'll see. High pressure still present. Kind of blocking things down in the Pacific. That's not unusual this time of year. The snow line from Whistler north. I mean, there's actually good snow on the ground at Whistler. I saw it falling. They've upgraded their cams on their website. So they're live cams now up on the mountain so you can see what's going on. Go take a look if you get a chance. It's pretty cool. And then, so precip, we'll see. With a La Nina pattern in play, I'd say we'll be lucky to get 85% of normal precip into California, and snow for this year about the same. Make your plans accordingly, but maybe we'll get lucky. I mean, we don't know how strong this La Nina is going to be. We're just starting to get into the season now. So fingers crossed that maybe we'll eke out a normal winter. That would be great. All right, that's the video for this week. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, click the Stormsurf icon down in the lower right-hand corner of your screen. That'll get you all signed up. If you have comments or questions, write them up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. And with that, we are done for this week. We will do it again next week, same time, same channel. Thanks so much for watching.